Okay, now you're going to solve equations by factoring. Typically what they mean is, especially when there's quadratics or anything um, with polynomial functions, when you're solving, you're finding out where are the x's going to touch the x-axis. So there's a few things you can tell just by looking at this right here. When it's already factored, you're going to hear your teacher say you're going to use the zero property. And what the zero property tells us is that if you take a number and you multiply it by 0, you get 0. Or if you take 0 and you multiply it by a number, you get 0. So when we apply it to this example over here, notice the right side is equal to 0. So if one of these is equal to 0, 0, according to the zero property, 0 times that whole parentheses will equal 0. Or if this parentheses is equal to 0, then this parentheses times 0 will equal to 0. So that's what the zero property means. One way to solve is just say, we're going to use the zero property. We're going to set each set of parentheses equal to 0 and solve. So for this one, we would subtract 3. Then we would divide 4. All right. So one of the places it's going to touch the x-axis is negative 3/4. And then over here, the second equation, one of the x values, one of the other roots. So at negative 3/4 and at negative 1, all right, so that's what they're looking for. Now notice, if we multiply 3 times 1, that's how we know where it's going to touch the y-axis. So this graph would look and make that look like a U. Parabolas are U-shaped. So when we're solving for factoring, we're looking for the two x values that sit on the x-axis. Okay. Oh, I was going to show you another way to think about it. Instead of using the zero property, well, to cause this thing to equal 0, do all of the opposite or inverse operations. So the inverse of subtracting 3 or of negative 3 is positive 3. For this one, the inverse of subtracting 1 or negative 1 is positive 1. The inverse operation to multiplying is dividing. So instead of going to all of this work, we can just look directly at the factoring and come up with it. All right? When there are two terms, you look at those two terms and ask, you're going to do the reverse distributive. So normally if you had 5 times v plus 1, you would do the distributive. That would be 5v plus 5. Whoops. In this case, both of those have a v, so I should have put a v there, and there we go. So that would have equaled it. All right. So what those two both have in common is a v. So we're going to do the reverse distributive. This v we're going to cancel. And then one of those. And then what that leaves is v plus 5 is equal to 0. And then anytime you have a v on the outside of parentheses, remember, pretend that was in its own set. Well, we could just set, v is equal to 0. So right away, even if that would have said 5v squared, the v is on the outside of parentheses, so that v is equal to 0. And the opposite of positive 5 is negative 5. And what I want you to do is put a solid dot at 0, solid dot at -5, and then halfway between at -2.5, somewhere down there will be the vertex point. Okay, let's keep going. Okay, these are ones where there's bigger numbers. The first thing you need to check, do all 3 of these have a number in common? And the answer is yes. They all have a 4 in common. So we're going to do the reverse distributive. Acts very much like division. So 4 divide 4, that leaves x squared. 40 divide 4, that's 40x divide 4 leaves 10x. 100 divide 4 leaves 25. And now we have this quadratic that we can deal with. So we leave the 4 there, and then we put our 2 sets of parentheses. Factors of 25, that add up to 10. Well, 25 only has 25 times 1, or 5 times 5. 5 times 5 multiply to be 25, and 5 plus 5 add up to 10. So this is x plus 5. So look at, when you do the opposite, you've got -5 twice. That's a multiplicity of 2. So x is equal -5 multiplicity of 2. And remember what I showed you all for the graph, what that means? So at -5, if it's a multiplicity of 2, it means it does not cross, it sits, and then it's going to touch way up there at 25. So that graph is going to look like this, and by the time it gets up there, that's 25 where it touches, but you don't really have to do that because that looks obnoxious. Yep, so that's what that graph would look like. All right, let's see if there's another one I should cover real quick. Okay, here is another one, but notice this side is not 0. So we're going to have to subtract 8 on both sides. That zeroes this out too. So what we have is 3m squared plus 9m. We don't need to put plus 0. And now these both share a 3m, both of them. So it's 3m is going to factor out. So this 3m gets factored out, so that goes away. One of those m's, that leaves an m. 9, when you factor out a 3, leaves a 3. This m, so that leaves 3m plus 3. Remember what I said, this is on the outside of parentheses. So this m is equal to 0. This m is equal to -3. Here, I'll do this. So then when we graph it, -3, 0, and it looks roughly like that. Okay, and I'll do a video, another one in a minute. All right, that's it for these. Solving by factoring.